Under power system analysis, under unsymmetrical fault, there are two types: shunt type of faults and series type of faults. Under shunt type of faults, we are already seen single line to ground fault, line to line fault, and double line to ground fault, even three-phase faults through fault impedance and without fault impedance. Now we will discuss series type of faults. Under series type of faults, there are three types in a power system: one conductor open fault, two conductor open fault, and three conductor open fault. Out of it, the last one, that is three conductor open fault, is not at all a fault itself, since all the three lines are open. Now here figure 5.56 shows a system wherein open conductor faults take place. Now we see the three lines here. This is line 1, line 2, line 3. The current flowing through the lines are IA, IB, and IC. Now here F and F dash represents the fault side. Okay, F and F dash represents the fault side. Here AA dash, BB dash, and CC dash represents conductors ends. AA dash, BB dash, CC dash is the conductor ends of lines A, B, and C. This is the lines here. Okay, this is general representation of a conductors in a transmission line or in a power system. Now let me discuss here. The voltage is denoted as VAA dash, VBB dash, and VCC dash in line A, B, and C, and its symmetrical components of individual are. Suppose the symmetrical component of VAA dash is denoted by VAA dash of 1, that is the positive sequence voltage, VAA dash of 2, negative sequence voltage, VAA dash of naught is the zero sequence voltage of voltage VA dash, AA dash. Similarly, you can write for VBB dash and VCC dash. These components are suitably interconnect depending on the type of faults, whether it's a one conductor open fault or two conductor open faults. This is general representation of the three network: positive sequence network, negative sequence, and zero sequence network. This positive sequence network all looks same here. Here the representation, here the current will represent IA1 in, IA1 is in and IA1 is out. Here the voltage is VA dash of 1, VA dash of 2, VA dash of naught. Here the current IA2 in and IA2, IA0 in and IA0 out. This is representation of positive, negative, and zero sequence. Depending on the type of fault, whether it's a one conductor open fault or two conductor open fault, you have to connect these three networks, as already you have seen, single line to line to line or double line to ground fault. Let me discuss the next one: open conductor or one conductor open fault. Here let us assume that the conductor A of a system gets opened as shown in figure here. Now the same first diagram here represented with what F dash is a fault here, fault point. Now as we know, one conductor open. See, now conductor A, there is here the conductor A is open here due to the fault F and F dash here on the power system here, and IB and IC are intact. Here there exists a shortcut. Now here you try the terminal condition. From this diagram, it's very clear that terminal conditions: IA is open, hence it is open here. The current will not flow through the other end here because it is open. IA is equal to 0. And here you can notice that VBB dash and VCC dash will be 0 since it is short circuit here. These are the terminal condition: IA is equal to 0, VBB dash is equal to 0, VCC dash is equal to 0. Since we have the equations are most for voltages, here you write symmetrical component of voltages. First you write for VAA dash. Here the voltages are VAA dash, VBB dash, and VCC dash. Here you write for, consider the line A. Here you write for VAA dash of 1 is equal to, as you know from symmetrical component of relation, 1/3 of VAA dash plus A into VBB dash plus A square into VCC dash. Substitute VBB dash and VCC dash here. We'll get 0. We'll get VAA dash of 1 as 1/3 of VAA dash. Similarly, get for the equation for VAA dash of 2 and VAA dash of naught. From all the three, what we can conclude here from equation 5.97 as VAA dash of 1 is equal to VAA dash of 2 is equal to VAA dash of naught is equal to 1/3 of VAA dash, which implies all the three voltages in positive, negative, and zero sequence impedance are same, which implies positive sequence network, negative sequence network, and zero sequence networks are in parallel. And one more condition: IA is equal to 0, which implies that IA0 plus IA1 is equal to IA1 plus IA2 is equal to 0. IA0 plus IA1, here the correction, IA2 is equal to 0. Of condition 5.97 and 5.98, we can write like this, as already we got from the equations. Voltages are in parallel, since you treat positive sequence network, negative sequence network, and zero sequence network in parallel here. And as you know, the here IA0 plus IA1 plus IA2 is equal to, from this you will get IA1 plus IA2 plus IA0 is equal to 0 as per the KCL. Clear? This is about how we can proceed with one conductor open fault. Next we get into the next series type of fault, that is two conductor open fault, and which you see here. Let us assume that two conductors B and C get open. B and C get open. at the fault points f dash as shown in the figure. From this terminal it's very clear that IB is equal to 0, IC is equal to 0, and VA dash will be 0. IB is equal to 0, IC is equal to 0, and VA dash will be 0. Hence, most of the equation for current, hence you write symmetrical components of current here. That's IA naught is 1/3 of IA plus IB plus IC. Similarly, get IA1 and IA2. From these three, you will get from equation 5.102 that IA naught is equal to IA1 is equal to IA2, which implies 1/3 of IA. Since currents are same, positive, negative, and zero sequence currents are same. Hence, the positive sequence impedance, negative sequence, and zero sequence impedance, they are connected in series. The terminal, one more terminal condition, VA dash is equal to 0, which implies that VA dash of 1 plus VA dash of 2 plus VA dash of naught is equal to 0. That is equation 5.103. From 5.102 and 5.103, we can conclude the interconnection of networks. Since they are here, since currents are in same, they are in series. Now you have to draw positive sequence, negative sequence, they are in series. Positive sequence network in series with negative sequence network, negative sequence network in series with the zero sequence again with the positive sequence network. Here you have to mark the respective current, IA1 here, IA2 here, and IA naught, IA1, IA2. IA naught is equal to IA1 is equal to IA2. At the respective place you write here VA dash of 1, VA dash of 2, and VA dash of naught. Hence, this is about series type of fault and the respective equation for one conductor open fault and two conductor open fault.